Well, g'day. Iron horse there. Birds are saying g'day too. So this is one I've been trying to get off my chest for a little while because it comes up quite regularly, and so I thought I'd just quickly address it because I've never actually seen it being fully addressed, even by the one who it was originally intended to intended to shame into exposing as flat Earth is false. And there was two of them from that mockumentary. It was supposed to be a documentary. I can't even think of it now. Flatten the curve, level the curve. On Anyway, some Argentinians made a documentary some years back, which gained a lot of notoriety, particularly because a couple of you would call them world famous flat earthers, Bob from Globebusters and Jeran from Jeranism. They were both sort of put on the spot a bit and technically tricked into saying things outside the realms of the proper standards of making a documentary. Like, you don't sort of film somebody seemingly in private, undercover type thing, and then edit it into another section of a video to make it seem as though the two things are related. But that is what they did, and I understand that documentary makers are out to get viewers. They don't really give a shit about the truth necessarily. And the Bob 15-degree drift one has been addressed multiple times before, and I'm not even going to touch upon that one. It's been addressed. Obviously, we see the celestials rotate 15 degrees per hour all the time. That's just a given. So, but the one is about with Jeran of Jeranism, who was, I don't know what's the word, induced. He was talked into. It was suggested to him that we could do an experiment, and it sounds reasonable and logical on paper. It is literally another version of the Bedford level experiment, which was done, back in the days of Robotham, or Parallax as he went by back in his day. And that version was basically, there was the Bedford canals, or the Bedford levels as they were called, and they were known to be dead straight for a good 6 miles, so that was a really good viewing point. So what you could do is get down close to water level, stand in the water with a telescope, and watch a boat row 6 miles. Now, according to Earth calculations of curvature, at 3 miles there should be a 6-foot drop, because the curvature drop is in fact 8 inches per mile. I don't care what people try and say, oh, that's a parabola. It may well indeed be a parabola once you get over 6,000 miles, which is the half of the frickin' or quarter of the ball Earth you think you live on anyway. So it's completely irrelevant to any practical observations we can make within viewable distance anyway. So 8 inches per mile squared is a true and accurate, or if you really want to be pedantic, it's 7.98 inches per mile squared by the number of miles. That is perfectly doable. You could work it out in kilometres as well. I don't have AutoCAD. I'm not going to sit and work it out, but it's doable. So if it was 6 miles, well, 6 times 6 is 36. Multiply that by 8. Now that off the top of my head, 6 8s are 48. Bloody hell, why'd I do this on camera? What was the question again? 36, the 3 8s are 24 plus, whatever. It's more than 6 foot, which is the amount of drop you get at 3 miles. It's not just 12 foot, you don't just double it. Fucking hell, I'm going to have to do it. What was it again? 6 miles. So 6 6 is 36. Normally what I would do is just do 3 8s are 24, so that's 240 plus 36, so 276. Then divide that by 12 is about 3 and can't even remember the numbers, that's the trouble. too many distractions here. There's big yellow-tailed black cockatoos. So anyway, it's probably about like more than 24 feet off the top of my head, just as a guesstimate, because I couldn't be stuffed calculating it properly, because there's 12 inches to a foot. That's why you divide up 12. So we're talking about 24 foot of drop from the level. So that's how far beneath the flag should be in the Bedford Levels experiment. And the way they disproved the Bedford Levels experiment is exactly the same method they used to trick Jeran into doing this experiment. And the way they did it with theirs is they used cardboard or whatever, some sort of board with holes cut into it. I can't remember the documentary now, it's a while since I've seen it, but let's say that they were 9 feet off the surface. So they went out for 3 miles, shone a laser through the first hole, 9 foot above the water level, then went another 3 miles, and then they wanted to see if that laser would align with the last hole, another 3 miles away. Now this is a factor of perspective, convergence, and distance diminution, which is not taken into consideration when doing such an experiment. So although it sounds logical, it sounds as though the laser should line up with the middle hole and the end hole. It's the same with the Bedford Level experiment when the bloke, I don't know his name either, who debunked it, did something similar at the 3 mile. When they did it, there was a bridge across at 3 miles. So what they did is they suspended, I believe, a flag or something from it so that it was the same height as the flag in the distance. And so if these things are aligned, then therefore it's a straight line. So therefore the Earth is flat. But because it doesn't align, because it's higher than the distant one, which is the same thing with the board with the hole in it at the 3 mile point compared to the one at the 6 mile point, they don't align, which then they say, well, that proves that it's a curve. Okay, it seems logical, and I can understand why the average globetard would understand and accept that, because we're told it's a globe. We look for proof of a globe. We don't look for proof of a way to debunk it. But if you understand the laws of perspective, these are the important things that I keep stressing in nearly all of my arguments again and again and again. There is a law of convergence. As you can probably see, there's a shipping container there behind me. And that shipping container at that height is the same height as it is just here. And if I tilt my camera a little bit further, you will see it's the same height. Now this is holding my camera level at eye level, and it's a bit hard to do because you've got to do everything in reversey-dersey. But that's the same height from here to there, but you can see as it gets further away it appears to get lower. That is convergence, the law of convergence, that everything above you appears to get lower in the distance. Hence why it looks like the sun sets, why clouds go behind trees and buildings even though they're miles higher than them. Everything appears to get lower, and so they converge behind one another in the distance. And so when we're looking then down a unobstructed view of 6 miles, then the things beneath us are ramping upwards. The other law of perspective is distance diminution. You'll see how the gaps in the shipping container are much larger, closer to us than they appear further away. That is the thing in, say, those pylons on Lake Pontchartrain, where they say they can see the curvature because the distance between things is getting narrower, and if you do it at the right angle, as the heights of things appear to get lower, it will appear curved. That's actually exactly the way pixels on your computer screen appear to give you curved letters and writing. You know, every symbol on your screen, you know, you see a 0, it looks like a circle. But if you zoomed right in on it, you'll see it's just a bunch of squares, flat and level squares. And so the idea of curvature in such a big frame, like the Lake Pontchartrain example, is merely a simple matter of a heap of straight squares creating the illusion of curvature. This distance diminution, convergence, combined together create that sort of illusion. So what we're seeing when we look across the flat surface is that as things shrink and converge upwards, they do not converge equally. Some people say there's this law of hang on a second, let me refresh my brain. Square law or something. No, it didn't work. The truth serum's failing. Like, there's something about the law of squared, you know, it's to do with light, generally speaking. They say if it's twice as far away, it's twice as dim, which I think is absolutely a load of bollocks, actually. Sorry, Bob, because I know you talk about the the law that's suddenly escaping me. I'll probably write it in the comments later because it will come back to me. It's one I'm very familiar with, but it's called the thing that's, you know, when it's on the tip of your tongue and it refuses to come to you. But basically what it's saying is that perspective, technically speaking, here's my hand at this distance. Now if I move it this far away, it's now 1x. If I move it the same amount away, it should be 2 times smaller than it is here. Now if I move it the same further forward, it's now 4 times bigger. And that's clearly wrong, because, you know, if I move it back here, I've only moved it, what, a few hands away. And it's not that much smaller. And so if I moved it all the way back here, it'll get smaller and smaller and smaller, but it'll eventually reach a point where it will hardly seem to shrink at all. So it's not a square law of square root law or whatever. Bloody hell. Geez, I wish I could remember that one right now. But distance diminution is not equal, is what I'm trying to point out. Like my hand here will appear this size, but if I move it way up here, it's obviously not, you know, massively bigger. Now if I call that 1 distance, and then I call this 2 distance, and I call this 3 distance, and I call this 4 distance, the 4 distance is not 4 times smaller than if I call this 1 distance, and this 2 distance, and this 3 distance, and this 4 distance. You know what I mean? It doesn't work. You have to have an actual standard of distance, a standard amount of distance to say what it is. And so when we apply it then to, say, 3 miles away, the amount of distance diminution of a thing is far greater at 3 miles, obviously, than at 3 inches. You know, it's a big difference. But once it gets to about 2 miles or 1 mile, then the distance sort of goes like this, then 3 miles is like this, and so on. So by the time you get to 6 miles, the distance diminution amount is only kind of like this. It doesn't go in equal proportional amounts as it seems to do up close. So what's happening is the distance diminution at 3 miles has basically artificially elevated because of the convergence factor. The convergence factor is ramping up at a certain amount, and that also diminishes the further you go, which is why at 3 miles, if you're 6 foot above sea level, that is generally considered to be your horizontal horizon point. So everything converges into a singularity under certain conditions, whereas in fact the Bedford level proves that's incorrect. You can actually see 6 miles, and yes, you can still see the flag above the water, but the amount that it has appeared to shrink compared to the amount it has appeared to go up is not proportional with the distance it had gone at the halfway point. It's far, far, far less. So it will appear to be much lower, creating the artificial construct in the mind of the viewer to say, well, look, we've just proven that it's this much lower than it is at the halfway point in appearance, therefore Earth curves. It's curvature. You know, it's crazy. It's crazy because it's the same thing what they did then to Jeran, is that because the ramping up to the 3 miles is far more significant than the ramping up effect for the next 3 miles. That next 3 miles will appear in this much space, whereas the first 3 miles will appear in this much space. So when you then hold a laser and point it through something going through this much space, the ramping up effect artificially raises it up through that hole. So therefore, when you get this much further away, that target point, the interesting point, must similarly be elevated, because you have not taken into consideration the point of view from where the laser began. It's the same as the telescope on the Bedford level through this much point of shrinkage, which is a lot less than the amount this much further away. It cannot elevate itself to the same extent. And so that creates the illusion of curvature. The only way you can truly do it is to use a very, very, very long hose, preferably a single one so you don't get leaks. But if you get a 6 mile long hose, do that at the same time. Connect a whole heap of hoses together and have clear hoses from one end to the next. And instead of using a visual, which always has those limitations of perspective and convergence and distance diminution, instead just lift the ends up of each one 6 inches above the water and measure it, and if both of them are 6 inches above the water, then that will prove that it is indeed flat and level, because that's a physical measurement, not a visual observation, which is fraught with the errors of perspective, or Flerspective, as the Globers love to call it, because they can't understand how a visual view of something is not a true capture, it's not a mathematical truth of what you're looking at. You know, they want to say that you can use trigonometry to measure something, but if you're looking 6 miles in the distance, as I was saying before, the 3 mile height has shrunk to this much, but the 6 mile height has shrunk to this much. So if you're using trigonometry and saying, well, the angle to that is blah blah and the angle to this is blah blah, and that's why you throw everything out by miles and miles and miles of recognition, by thinking that trigonometry can be a useful tool when you're only using visual stimulus, but you're using simple geometry without taking into consideration all of those factors of perspective. I hope I've made my point. Thanks for watching. Cheers.